Hello, this is Chuck Bejan, and this is my project for Cycle 9, which is the User Equipment, or UE Locator. And what this tool does is it reads in the location of 3 cell towers and 3 readings from those cell towers and determines the location, triangulates the location of the user equipment or the mobile device that you're trying to find. It outputs the location as a KML file, which can be used in Google Earth to graphically display on the map the cell tower locations, the range rings around the cell towers, which is based on the readings from the data file, determine the radii of these range rings, and graphically show the location of the user equipment, which is shown as the intersection of the 3 range rings. So we're going to run through the code real quick, and then there'll be a separate video showing this being used. One of the things that was new for me with this project was use of the simple KML library, which is a way to produce KML files from Python. It does have some limitations, one of which being that it can't draw a circle very well. So to draw a circle, I had to use another library called Polycircles. And Polycircles is kind of neat. It can draw a circle or create input to simple KML that allow simple KML to draw a circle. However, you have to draw an inner and outer circle. It's really a polygon that it's drawing and approximating a circle. And we'll see a little bit of that below. But anyhow, let's start off with class tower at line 18. And this class models a cell tower. It has the lat long of the tower, the transmit frequency in hertz, the power in watts, and the gain of the transmitting antenna. It also has a plot method which will plot the location of the tower in KML as an icon that's going to be displayed on a map in Google Earth. You'll notice on line 37 that there's a URL there going to an icon, and that icon is the icon that will appear on the Google Earth map to show the location of the cell tower. And you'll see it looks like little triangles. But anyhow, that is the tower class. The next class down on line 42 is UE read. UE for user equipment. And it's a UE read. It's a reading from the user equipment. These readings can be one of 2 forms. They can either be a received signal strength reading, or they could be a propagation time reading. 2 algorithms for computing distance from the cell tower. One is to use received signal strength, which attenuates according to a certain formula. The other is to use the propagation time, which we can multiply by the speed of light to determine the distance that way. So the distance method on line 52 takes a look at each reading and says, well, what type of reading is this? That's what line 63 is saying. Is it a received signal strength, an RSS reading? If it is, go ahead and use the attenuation formula to compute the distance to the user equipment. If it's not received as signal strength, then it must be a propagation time reading, in which case we use the speed of light formula to determine the distance. That's what you see on 73. Anyhow, on line 78, these readings also have a plot method, and that plot method plots the range ring using the distance as the radius of the ring around the cell tower. And again, because of the way simple KML does things, we have to use polycircles. We have to draw two circles, an outer and an inner, with the difference in the radii between the inner and outer circle being the thickness of the resulting circle. That's why you see an outer circle on line 88 and an inner circle on line 100. So if you're wondering why we're drawing the circle twice, it's because just the way polycircles work. Anyhow, we draw our circle as a polygon in KML and generate our KML to represent our range ring. On line 115, read data file. This is just a standard method, really, nothing special here. We're reading a text data file. We are discarding the comments that we find, and we are building either tower objects or reading objects, UE reading objects, depending upon what's specified in the data file. And you'll see on line 145, it's a tower, we build a tower object. On 147, if it's a reading, we build a UE reading object. And if it's neither of those, we print an error message. We have parse args, which is the method to parse our input and output file. The user has to specify both on the command line. If they don't, then Python will actually flag an error saying both parameters are needed. So the program actually starts out by parsing its command line arguments, and if both the input file and output file are present, it will read the input file, create the three tower objects and the three reading objects, create range rings once it's computed the ranges, and I set the colors for these rings on line 212 to red, white, and blue, just because when I started working on this, it was near July 4th, so they're patriotic colors. But on line 216, you'll see where we go through the readings and we begin to plot our range rings, build them in KML, and add them to our KML object. When we're done, on line 221, we save the KML that we've created to the output file. So our output file is a KML file that contains 3 cell towers indicated by icons, geographically located at the correct positions, and 3 range rings emanating from those cell towers based upon the 3 readings that we put in the file. So now you're probably wondering, well, what does a data file look like? Well, here's a data file. Lines that start with hashtag are comments. Lines that start with the icon or the acronym TWR are towers. I've got 3 towers here on lines 2, 3, and 4. They're all AT&T towers. I arbitrarily made up the identifiers. The latitude and longitude are real. They came from, they're actually real towers near my home. The frequency, 172.5 megahertz, frequency listed in hertz there is made up. And the transmit power and antenna gain are arbitrary values I put in for demonstration purposes. But this will be the format of a tower in this data file. Likewise, the readings on lines 7 through 9, they all start with RDG for reading. And the second field is the cell tower they correspond to. The third field is either RSS or time, RSS being signal strength reading and the time reading being a propagation time reading. You'll notice that the first 2 towers have RSS readings on line 7 and 8, but the third tower, the third reading, is a time value. So that when we process that, we're going to use the speed of light formula instead of the attenuation formula. All right. So the next thing to do is to demonstrate this, and that will be shown in a separate video.